Bonjour mes amis! Today we're going to talk about factoring higher order quadratic form, which we've kind of alluded to already. So you're going to be pretty good at this because you've actually already been practicing. So if we want to factor a higher order quadratic form, a higher order polynomial in quadratic form, we first need to put it in standard form. Always a good first step. Put in standard form. Okay, put in standard form, which is going to mean highest exponent comes first, and then go in descending order. Highest exponent term first, then descending order. Okay? Factor out a GCF if necessary, of course. Look at the first exponent. Make sure it is double the second exponent. Okay? Then you're going to use your ACB tree and factor until you can't factor anymore. So let's look at some examples. Is this in standard form? Is the highest exponent term first and then in descending order? Yes, it is. Do we have a greatest common factor? Pretty sure we do. What goes into 18 and 30 and 300? We could take out a 6 and be left with 3x to the 4th minus 5x squared minus 50. All right. Now let's make sure our first exponent is double that of the second. First, is that double? Yes, it is. Okay, great. So we have a higher order polynomial that's in quadratic form. Fabulous. So now let's use our ACB tree. A is going to be equal to 3, B is equal to -5, C is equal to -50. So our ACB tree says I need two numbers that multiply to be A times C. A times C is -150 and B is -5. Two numbers that multiply to be -150 and add to be -5. Oh, I got it. How about -15 and 10? Yeah, that'll work. And now, just like we did before with our ACB tree, we're going to split our middle term. Our middle term has an x squared on it. So we're going to tack x squareds onto these two numbers we came up with. So we've got 6 times 3x to the 4th. We keep that. Minus 15x squared plus 10x squared minus 50. Okay, so kept the first term, kept the last term, split the middle term, and then we'll group the first two and the second two, take out a GCF of each, which here we could take out a 3x squared from both and be left with x squared minus 5, right? And here we can take out a 10 and be left with x squared minus 5. We did a great job because the parts in parentheses are the same. So we'll have the part in parentheses as one of the factors. I still have my GCF in the front. And 3x squared plus 10. Now this is not a difference of squares, so that is as good as we're going to get. There's our answer. Let's do it again, shall we? Example number 2, are we in standard form? Is the highest exponent first and then in descending order? Yes. Do we have a GCF to factor out? Yes, we do. GCF, let's take out an m. So we'll have m to the 6th plus 4m to the 5th. No, plus 4m to the 3rd plus 3. Okay. Is our first exponent double that of our second exponent? Is 6 twice as much as 3? Yes, great. So let's do our ACB tree. A is 1, B is 4, C is 3. We need two numbers that multiply to be, let me slide my paper up here, two numbers that multiply to be a times c, a times 3, 1 times 3 is 3, and add to be b, which is 4. So we're going to get 1 and 3. And now, since our a term was 1, we can skip right to the factors here. Just be careful. We're going to have, maybe I'll put it all the way out. Yeah, I'll show you. We'll do it all the way out from our ACB tree. We had an m. Let's split our middle term. This will be m to the 6th plus 1m cubed plus 3m cubed plus 3. Group the first two, group the second two. Take out our GCF of each of those groupings. Here I'm going to take out an m cubed and be left with m cubed plus 1. And here I'll take out a 3 and be left with m cubed plus 1. Parts in parentheses are the same. So the part in parentheses is one of the factors, m cubed plus 1. The GCFs we took out are the other factor, m cubed plus 3. And don't have any difference of squares. So, oh, poop. But we do have a sum of cubes. Oh, which we do know how to do now, right? This is a sum of cubes. So we're not done yet. So we got to use our sum of cubes formula, which you have to memorize. Oh, gosh. Remember, our sum of cubes, a cubed plus b cubed, is equal to a squared minus ab plus b squared. Okay, so this will factor to m cubed, or m is going to be our a, b cubed here, 1 is 1 cubed, so b is 1. So we've got a equals m, and b is going to equal 1. Plugging that into our sum of cubes formula. So we'll have m plus 1 times m squared minus a times b. A is m, b is 1. So minus m plus 1 squared, which is 1. And then we've got our m cubed plus 3. And now we're done. Now we're really done. Whew, that was close. Almost forgot about a sum of cubes. Remember that trinomial that came from the sum of cubes is never factorable, so we don't have to worry. It looks like it might be factorable, but we know it's never factorable, so we don't have to worry about that. All right, moving right along. What are we supposed to do first? Put it in standard form. Are we in standard form? Yes, we are. Can we take out a GCF, a greatest common factor? I'm pretty sure we can. We can probably take out at least a, they're all even. Yeah, let's take out a 2. You know what? Let's take out a negative 2. I like when my a term is positive. Let's take out a negative 2. And we'll be left with 2x to the 4th minus 15x squared minus 54 divided by 2 is 27. Okay. What were we supposed to do next? I can't remember. Standard form, GCF. Oh, make sure the exponent, the first one is double that of the second. Is the first exponent double that of the second? Yes. So then we do our ACB tree. ACB tree. A is 2, B is negative 15, C is negative 27. Okay. A times C, 2 times negative 27 is negative 54. We're going to add to be negative 15, two numbers that multiply to be negative 54 and add to be negative 15. Need a big number that's negative. Let's do negative 18 and positive 3. So let's split our middle term. We'll have negative 2 times 2x to the 4th minus 18x squared plus 3x squared minus 27. Group the first two, group the second two, take out GCFs of each of the groups. Here I can take out a 2x squared and be left with x squared minus 9. Ooh, I see that's a difference of squares. Here I can take out a 3 and be left with x squared minus 9. We did a great job. The part in parentheses is the same. So we've got negative 2 times that part in parentheses times the GCFs we took out. But like I said, that sucker is a difference of squares. Diff of squares. This is going to become negative 2 times x plus 3 times x minus 3. This came from our difference of squares. Times 2x squared plus 3. And that's as far as we can go. And last but not least, let's talk about factoring this x to the 6th minus 1 using two different methods. We could use the difference of two cubes. Whatever do you mean, Miss Megan? Well, x to the 6th as a difference of cubes would be x squared. Oh man, my pen is just dying. And 1 is, of course, 1 cubed. Gonna have to send you to the pen graveyard, pen. Bye, buddy. You've been real good to me. Real good. So, in our difference of cubes formula, or that was a cubed minus b cubed. Whoa. That factored to a minus b times a squared plus ab plus b squared. So our a here is x squared, and our b here is 1. So this will factor to a minus b, x squared minus 1, times x squared squared is going to be x to the 4th, plus x squared times 1, which will be x squared, plus 1 squared, which is 1. Now, this trinomial here, never factorable. This right here, though, is a difference of squares. So that's factorable. So this will become x plus 1 times x minus 1 times x to the 4th plus x squared plus 1. We could also factor this doing a difference of squares. Well, what would that be? This would be x cubed squared minus, again, just 1 squared. Our difference of squares would factor to x cubed minus 1 times x cubed plus 1. But then we would see, what do we see here? I see a difference of cubes and a sum of cubes. Whoa. So using our difference of cubes formula, this would factor to x minus 1 times x squared plus x plus 1. And using our sum of cubes formula, this would factor to x plus 1 times x squared minus x plus 1. Whoa. So this one has 3 factors. This one has 4 factors. Which one is factored more completely? This one. This is factored completely, more completely. It's got more factors. More completely. So keep that in mind. If you got an option between using cubes and squares, Do the thing that's going to get you more factors to factor more completely. All right, lovelies, that's it. Kind of a recap of stuff that we've already done. Major steps to factoring higher order polynomials in quadratic form. Put them in standard form, take out a GCF, make sure the first exponent is double that of the second, do your ACB tree, and then factor till you can't factor no more. Love you so much, keep on that hustle, and I'll see you next time.